Hello. Welcome to Career Launcher, and we are going to talk about quantitative aptitude CAT 2025 geometry. And in this session, we are going to talk about triangles. We have already completed one session on triangles, and this is the second session of triangles. So, basically, in this session, what we are exactly going to do, we are going to talk about the centers of a triangle. So we are going to talk about centers of a triangle. So basically what kind of centers of a triangle we have, and how things are formed. So for example, I am going to start with medians, so, or I would say centroid. So one of the centers of a triangle is called as centroid. Now what is centroid, and what is the property of centroids, we are going to discuss about that. So first of all, the centroid is the intersection of any two medians. Now, what is a median? So median is from vertex to midpoint. So when you draw a line, that line is called as median. So from vertex to, if you join the vertex and midpoint of the opposite side, that line is called as median. Again, from vertex to midpoint of other side, that is called as median, and intersection of those two medians is called as centroid. Similarly, this is also going to be a third median. So intersection of medians is called as centroid. Now what happens is that this centroid, if you see how many triangles you are going to get, so you are going to get total of 6 triangles. So for example, this is A, this is B, this is C, and let's give the names. This is D, this is E, this is F. So AD is a median because it is the D is the midpoint of BC. So AD is a median, B is a median, CF is a median, and let's call centroid as O. So you are going to get 6 triangles. One is AFO, second is AEO, third one is BFO, then BDO, then CDO and CEO. So there are going to be total 6 triangles, and area of every angle, area of all 6 angles is equal. All 6 triangles is equal. So if let's say total area is 6, then area of each triangle is going to be 1. So that is the first property of a centroid. The second property of the centroid is centroid always divides median in the ratio of 2:1. So this is 2, this is 1. So it is always going to be 2:1. Now, an important point is when you join from vertex to midpoint, it's not necessary that this is going to be perpendicular. This might be perpendicular, this might not be perpendicular. If it is equilateral triangle, BD is going to be median as well as it is going to be perpendicular. But ABC is not equilateral triangle, then it might be perpendicular, might not be perpendicular. So AO is to OD is going to be in the ratio of 2:1, irrespective of type of triangle. So this is the first triangle, first center that we are going to talk about, that is centroid. Now, what is other this one, that is in center. Other center is in center. Now, what is in center? In center is, in the last class we have talked about one thing, that is area of triangle. In that area we have I have given one specific area of triangle, that is R into S. R is in radius, S is semi-perimeter. So basically what exactly R is and how it is formed. Okay. So you have A, you have B, you have C. Now you draw the angle bisector. So angle bisector means this is what angle bisector looks like, means this and this angle is equal. Similarly, second angle bisector, and similarly third angle bisector. Now this angle, this intersection of angle bisectors is called as in center. Okay. Now from that in center, when you draw the perpendicular, this length, this is called as in radius, and that is R. And by taking this radius, when you draw a triangle, when you draw a circle, that circle is called as in circle, because length of perpendicular on any side is always going to be same. So basically, if this is R, this is also going to be R. Now, what is the property of in center? That if this angle is A, this angle is going to be 90 plus A by 2. So if I'm talking about in center, so basically let's say this is in center, I'm joining this. So if this angle is A, this angle is going to be 90 plus A upon 2. That's the property of in center. And apart from this, there is nothing. So the second is, if you know how it is formed or how it is not formed, it doesn't make a lot of difference. It is in center is simply intersection of your angle bisectors. Centroid is in intersection of your medians. Now third one is circumcenter. What is circumcenter? So circumcenter is intersection of perpendicular bisectors. Now, what is perpendicular bisector? For example, this is a triangle ABC. Now, let's call it A, let's call it B, let's call it C. So, this is midpoint. From midpoint, you draw the perpendicular. Now, it's not necessary that it passes through the vertex. It might pass through vertex, it might not pass through vertex. Now, second perpendicular bisector is this. Third perpendicular bisector is this. Perpendicular bisector means it passes through the midpoint of the side and it is perpendicular to that point. It's not necessary that it passes through the vertex. It might pass through the vertex, it might not pass through the vertex. So intersection of those points is called as circumcenter. Now let's say this is circumcenter. Now from I am drawing it separately. Now this is circumcenter. Now if I'm talking about this, this, all three lengths are going to be equal. Take this as a center and this length as a radius, and you can draw a circle from here. Now that circle is called as circumcircle and this length is called as circumradius. And in the last class, we have seen that area of triangle is given by ABC upon 4R. So that capital R is actually this radius that we are talking about now. Now, what is the property of it? That is, if I say this is circumcenter, I join this, and let's say this angle is A. So this opposite angle is going to be twice of that angle. In center, it is 90 plus half of that angle, and in circumcenter, it is twice of that particular angle. That's it. So there are two important properties. It is formed by I would say that is perpendicular bisectors. Second, area of formula of area is ABC upon 4R. Second, it creates an angle of twice of the original angle. Now, the third one, the last center that we are going to talk about is going to be your orthocenter. Okay. Now, what is orthocenter? Orthocenter is called as the intersection of perpendiculars. The intersection of perpendiculars, not perpendicular bisectors. So perpendicular means from vertex to base, you draw a perpendicular. Now, is this supposed to be midpoint? Not necessary. It might be midpoint, it might not be midpoint. It won't make a difference. Okay. Now, the second perpendicular. Now, third perpendicular. And you see, this is angle. So basically, if this angle is A, this is your orthocenter. Intersection of all three perpendiculars is called as orthocenter. If this angle is A, then opposite angle is going to be supplement of that angle. That is going to be 180 minus A. And apart from that, orthocenter has no property. I haven't seen the usage of orthocenter, I think, in last 7, 8, 10 years. Perhaps you might get the question on orthocenter or not. There is only one property, that the angle on orthocenter and opposite angle, they are always supplement. And apart from that, there is no other property of orthocenter. Okay. Now, there are quick formulas, if you can remember, that's going to be helpful. That if I'm going to talk about right angle triangle. So in right angle triangle, this is A, this is B, this is C. So in right angle triangle, the in radius is always equal to A plus B minus C upon 2. And the circumradius is always given by C upon 2. These two are important points, and it is true for right angle triangle. This is true for right angle triangle. Now, if I'm talking about equilateral triangle, so in equilateral triangle, how we can find out? In equilateral triangle, if this side is definitely A, this is H. So in radius is given by H upon 3, and circumradius is given by 2H upon 3. So these are the formula for in radius and circumradius for specific triangles in right angle triangle as well as in equilateral triangle. That is always going to be true, and we already know that H is equal to root 3 by 2 times A. We have already discussed this in previous class. Okay. Now in equilateral triangle specifically, your in radius, circumradius, centroid, orthocenter, all of them are always going to be equal. All of them, because if you see in equilateral triangle, when you draw the perpendicular, it bisects the base as well as bisects the angle that we have already discussed in the previous class. So basically when you draw the perpendicular, so it is already a angle bisector, it is also a perpendicular bisector, it is also a median, as well as it is also a perpendicular. So if it is a perpendicular, then it forms orthocenter. If it is perpendicular bisector, it means it is definitely going to form your circumcenter. If it is angle bisector, then it is definitely going to form incenter. And if it is if it is a median, then it is going to form centroid. So all four centers overlap in equilateral triangle. So from there we can directly get the formula of this, because centroid divides the perpendicular in the ratio of 2:1. So this is actually going to be your circumradius. This is your going to be end radius. So that is going to be 1/3 of H. This is going to be 2/3 of H. Okay. Okay. So now we are going to see few questions and solve them. Okay. So basically, what does it say? From a triangle ABC with sides length 40, 25, 35, a triangular portion GBC is cut off. Okay. Okay. So there is a triangle that is 40, 25, and 35. Okay. A triangular portion GBC is cut off. Okay. And it is talking about the area of remaining triangle. Okay. So this is A, this is B, this is C, and it is talking about centroid is G. Okay. 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 So this is 5 into 5, 5 into 7, 5 into 8. It doesn't form right angle triangle. Okay, so basically I need to find out the area of this triangle first. Okay, this is G. Okay. Okay. So basically what is the area? So first of all, I'm going to calculate S. So what is S? S is going to be A plus B plus C divided by 2. So that is going to be 40 plus 25 plus 35 means 60 divided by 2. Okay. So basically S comes out to be 50. Okay. I'm going to use Heron's formula. So area comes out to be square root of S, that is 50, into S minus A, means that is 10, into 25 into 15. Okay. So S minus A, S minus B into S minus C. Okay. Okay. So this is square root of 25 is 5. Okay. 50 into 10. So 10 into 10 is going to be 100. So that comes out to be 10 into square root of. So that is going to be 5 and 15. So that is going to be 75. Okay. So this comes out to be 5 more comes out. So that is going to be 250 into root 3. Okay. So my remaining area should be smaller than this. Okay. So how I'm going to calculate the answer? Now try to understand. When we were discussing about centroid, I told you that total 6 triangles are formed. and each triangle is going to have an area of 1/6 of the total area. So what is the area of this part? That is going to be 250 root 3 divided by 6. Okay. So this comes out to be 125, cancelling by 2. This comes out to be 3. So this area comes out to be 125 divided by root 3. Okay. Now, if you are cutting off this portion, so how many smaller triangles are remaining? 1, 2, 3, and 4. So what is the remaining area? That is going to be 125 upon root 3 into 4. So answer of this question is directly going to be option 2. That's it. We got the answer. We don't have to worry much about it directly. For this, you need to be very clear that if I'm talking about the medians, then if you draw the 3 medians, 6 triangles are made, and area of each triangle is always equal, and you can solve those questions easily directly. Okay, now let's move on to the next question. What does it says? Let P be an interior point on right angle triangle, isosceles right angle triangle with a hypotenuse B, AB. The perpendicular distance from P. Okay. So what I'm going to do, it is talking about isosceles right angle triangle. So in isosceles triangle, two sides are going to be equal. So it is going to be, let's say this side is x, this side is x, and this side is 2x. Sorry, root 2x. So isosceles triangle means two sides are equal, two angles are equal. So it is going to be 45, 45, 45, 90, 45, 45, 90 triangle. And we already know that in 45, 45, 90 triangle, the ratio of sides is 1:1:root 2. Now, it says that distance of P from this. So from one interior point, you have drawn the perpendicular. Okay. So this is a perpendicular, this is a perpendicular, and this is also a perpendicular. Okay. Now question is talking about that if the perpendicular distances from P are are this, then what is the area? Okay. So this is C. Now question is talking about what is the area of this. Now I am assuming that this, and this, all three of them are going to be what? So all three of them are equal. So this is definitely going to be in center. Okay. Now what is in center? In center is given as, so basically this is going to be in radius, this is going to be in radius, this is going to be in radius. Now what is in radius? That is A plus B minus C divided by 2. So that is going to be x plus x minus root 2x divided by 2. Now this is one length. So 3 lengths are going to be into this, and that is equal to 4 times root 2 minus 1. Okay. So from here, I am directly multiplying with 2 on this side. So I am going to get 2x. 2x into 3 is 6x minus 3 root 2x, and that is equal to 8 times root 2 minus 1. Okay, fair enough. So 3 root 2x, if I take common, then I'm going to get root 2 minus 1. So this is going to be 8 times root 2 minus 1. So this cancels out. So I got the value of x is 8 upon 3 root 2. Okay. Now what the question is saying, perpendicular distance from P to each side is this. Okay. Okay, so basically what we are doing over here, let me reread the question. Okay, I think I made a mistake over here in reading this question. So it says that the perpendicular distance from P to each of the points is this. So it means it is already saying that this length and this length and this length, all three lengths are equal. And all three lengths are equal to 4 times root 2 minus 1. It means this must be in radius. So basically, the mistake that I have made in this question so far, that it is not a summation of all three in radius, it is actually only one in radius. So that was a mistake I have made over here. Eventually we are perfectly fine with the concept. So this is already given. So what I'm going to do, I'm going to take root 2x common over here. I'm going to get root 2 minus 1, and 2 is going to be multiplied on this side, so that is going to be 8 times root 2 minus 1. So now root 2 minus 1, root 2 minus 1 is cancelled out, so x comes out to be 8 upon root 2, or I would say 4. Okay, here I can say this. Now, what is the area of this triangle? That is going to be half into x into x. So that is going to be half into 4 root 2 into 4 root 2. So root 2 cancels out, it is cancelled. So basically answer comes out to be 16. So answer of this question is going to be 16. So basically, at what point I realized that I made a mistake? Because when I figured out that x is equal to 8 upon 3 root 2, and this is half into x, that's the area of the triangle. But in that case, if you see, I was getting answer in decimal, and I've been consistently telling everyone that in a question that is theta, your answer will never be decimal. Your answer will never be in fraction. So whenever you make a mistake like this, the question itself is telling you that you are making a blunder over here. You will realize that there is a mistake somewhere. Right. Now let's move on to the next question. What does it say? So it says that given an equilateral triangle T1 with side of 24, the second triangle T2 is formed by joining the midpoints. The third triangle is formed by the midpoints, and so on. It is infinite things. So first of all, let's understand one point over here, that if I am talking about the not equilateral triangle, because in this question equilateral triangle is a little important, but conceptually equilateral triangle is needed to calculate the first area. Apart from that, instead of equilateral triangle, if you have some other triangle itself, the answer would have been same. So this if there is a triangle not equilateral, if you join the midpoints of that triangle, so basically you are going to get a triangle like this. So let's say this is A, this is B, this is C, and you are joining the midpoint, so you are going to get a new triangle DEF. Okay, so perimeter of DEF is always going to be half of the perimeter of triangle ABC. Always. If DEF is formed by joining the midpoints. The second concept is area of triangle DEF is always going to be 1/4 of the area of triangle ABC. Always remember this. So when I am talking about the perimeter in any triangle, if you join the midpoints, the perimeter will always be half of the initial area. Perimeter will always be half of the initial perimeter. The area will always be 1/4 of the initial area. Always remember this. So in equilateral triangle, the side is 24. So what is the first area? So area is going to be root 3 by 4 times a square. So that is 24 into 24. That is the area of the first triangle, that is T1. That is 6. So this comes out to be 144 root 3. That is the first area. Now, the first triangle is formed. So basically the first triangle is, it looks like this. Its area is 144. Now you have joined the midpoint. So what is going to be the area? That is going to be 144 root 3. That is the first triangle. The second triangle is going to have 1/4 of 144 root 3. What is the next area? That is going to be 1/4 of this triangle. So that is going to be 1 by 16 of 144 root 3, and so on. Now, can I say, is it a GP? Yes, it looks like a GP and it is a GP. So what is the sum of all those values? So I am going to take 144 root 3 common. I am going to get 1 plus 1 by 4 plus 1 by 16 plus 1 by 64 and so on. So it is what kind of GP? It is infinite GP. So what is the sum of infinite GP? That is A, that is 1 upon 1 minus R. Okay. So what I'm going to get 144 root 3 into 4 upon 3. This becomes 3 upon 4. So this becomes this. Now this comes out to be what? 48. So 48 into 4 is going to be 192 root 3. So answer of this question is going to be option B. That is 192 root 3. Now in this specific question, we learned a new concept. That is this. If you join the midpoints of a triangle, you are going to find a new triangle. It is going to have a perimeter half of the initial triangle, and its area is always going to be 1/4 of the initial triangle. Okay, now let's move on to the next question. What does it says? It says that the length of each side of equilateral triangle ABC is 3. Okay. The length of each side of equilateral triangle ABC is 3. Okay. DB a point. Okay, so I think I need to draw it a little bigger. So this is A, this is B, this is C. Now DB a point such that area of triangle ADC is half the area of triangle ABD. Okay. So D is a point somewhere here. Now this is D and this side is 3, this side is 3. And area of ABD is twice that of area of ADC. If you remember that in the last session of geometry, what we have learned that if you join vertex and base, if the ratio of bases is A is to B, then ratio of area will also be A is to B. Now, if you see the ratio of area is 1 is to 2, it means the ratio of bases will also be 1 is to 2. So this is going to be 1, this is going to be 2, and it is exactly going to be 1 and 2 itself because the total side length is 3 itself. Okay. Okay. Now, I am joining this. I am drawing the perpendicular. Okay. Now, in equilateral triangle, perpendicular bisects the base. It means this length from this to this length is going to be 1.5. So what is going to be this length? BD total is 2. From here to here, let's call it E. BE is 1.5. So AD is going to be 1 by 2. Okay. AE is perpendicular. So what is the length of perpendicular? That is root 3A times root 3A upon 2. So AE is equal to root 3 by 2 times A. A is side. So this comes out to be 3 root 3 upon 2. Okay. And ED is your 1 by 2. So if I draw this triangle separately, that this length is 3 root 3 upon 2. This length is 1 upon 2. This is 90 degrees and this is 80. So what I can do, AD square, I can simply use Pythagoras theorem where AD square is equal to this square, that is going to be 27 upon 4 plus this square, that is plus 1 upon 4, and that is equal to 28 upon 4. So this value comes out to be 7. So AD square comes out to be 7. So AD comes out to be root 7. That's it. So this is how we are going to approach the question, and this is the how we are going to solve the question. Okay. Now let's move on to the next one. What does it say? That suppose the median BD and CE of a triangle intersect at point O. Okay. Okay. So BD and CE. The question is not talking about it is equilateral triangle. Okay. And it is talking about medians. Okay. So let's call it A. Let's call it B. Let's call it C. Okay. Now BD. So this is median is D. So D has to be midpoint. CE. This is supposed to be E. And these two intersect at O. Okay. If area of triangle ABC is 108, And the question is talking about what is this area. Okay. So what I'm going to do, I'm drawing this separately. So I have AEO, ADO, BEO, let's say it is F, BOF, COF, and COD. So all these triangles are going to have same area. Okay, so how much area these triangles are going to have? So these triangles are going to have an area of 1/6 of 108. Okay, so each triangle is going to have an area of 80. Now I am going to draw this. So basically I can say this is 18, this is 18, this is also 18, this is also 18, this total area is 18, this total area is 18. So I can tell all those things. Now I am going to draw separately different triangle, that this is B, this is E, and this is D. Okay. I am joining this and this. That is O. This area is 18. Already figured out. Now question is saying that the property of this is D. Now question says the property of centroid is it divides the median in the ratio of 2:1. 2:1. Okay. So basically, if ratio of side is 2:1, what is the ratio of area? That is also going to be 2:1. So if this is 18, what should be this area? This is 9. So area of triangle EOD will be equal to 9. And that's it. You don't have to solve much. If you know, understand the property of median or centroid, you can directly calculate the answer of this question. Not too much, too difficult to solve this. And it doesn't make a difference whether it is equilateral triangle or any other triangle. When you draw three medians, you are going to get six triangles. Area of every triangle is always going to be equal, and it is going to be 1/6 of the total area. So by using that concept itself, you can solve any question. You don't have to worry about it whether the triangle is equilateral triangle or isosceles triangle or any other triangle. Um, that's it. And with this, we conclude this session. So anyone has a doubt, you can ask me that out. And thank you.